area formula is integral of a raised to b function in x, and it is now going to be dx. Okay, clear? So given, so let's make a problem here. Find the area bounded by this function and the x-axis from x greater than or equal to 0, lesser than or equal to 20. Okay, so to understand this, at least to have a visual understanding of it, I would suggest that you graph. Okay, clear? So you can use any graphing method that you can think of. Okay, use any graphing method that you can think of that will make your life easier. Okay, so easiest method to use is the intercept method, right? Okay, what are the intercepts? Can someone give me the intercepts?
Y is 20.
So 5, 10, 15, 20. Okay, X.
X is 10.
5, 10. Okay. So if I connect them with a line, it will give me something like this, right? Okay. But then where is the area that we are being asked to solve? It's an area bounded. When you say bounded, it is surrounded by the function. That's the function. It's surrounded by the function. That's y equal to 2x plus 20 together with the x-axis, this, from
0 to 20.
From 0 until 20. 5, 10, 15, 20. So that means until until here. Okay. So what area is that? This one. Okay. So that's the area that we want to find. Okay. So how do we solve that? All we need to do is to apply this formula. That will be, okay, just imagine this one. This is dx. That means you are getting a very small portion, in x, this one, that is our dx. And you are now going to be moving it from 0 until, you're going to slide this from 0 until 20. Okay? You get the idea? You're going to move it from 0 sampai 20 in order for it to cover everything. Okay, so that will now be area is equal to integral of from 0 to 20 of the function. What will it be? What's our function? In x.
2x plus 20.
2x plus 20, and that's in dx. Okay, what's the integral of this?
X squared plus 20x.
X squared plus 20x evaluated from 0 to 20. So what's the area? That will be 20 squared plus 20 plus times 20 minus, technically becomes 0. Correct? Am I correct? So how much?
800.
800?
Yeah. Yeah, 800.
square units, SQU. Correct, right? 2x will be x raised to 2 over 2. So choret, x squared plus 20x. Okay, correct. So that's 800 square units, this one. Okay, so next. How about if I'm going to use the same, okay, same function, same everything, except I change the limit, okay? So that will still be y, okay? Y equal to 2x plus 20 together with y equal to 0, which is our x-axis, correct? Y, okay, just say x-axis. From this time, x lesser than or equal to 20, lesser than or equal to 0. What will you get? Basically, it's the same thing, right? You will be using this formula, but then our limits will be different. Our limits will be from, what this? Ah, sorry, that's mean 20 to 0. So becomes
Negative 20 to 0.
So when you evaluate it, what's the area?
But
Okay,
teacher,
where is
it
it?
negative 20, teacher?
Hmm?
Oh, wait,
Where is
never.
this one?
Okay, okay,
That is now 5, 10, 15, 20. So the limit now is from this side, correct? From this side going to here. So let's label that in pink. So it will be from here sampai null. So the one that we are trying to look for is this. Okay, what happened? Let's use the pink. Okay, from here, so that's the area. Okay, clear? That is now x-axis bounded or bounded by the x-axis and the function, x-axis and the function. So going up. What's the area? What do you get?
Is it 0, teacher?
Oh, yeah, you're getting 0. You're not the only one getting 0, right? Who else is getting 0?
I did as well.
Okay. So there's a question, right? It's questionable. Why are we getting 0 when clearly, according to the graph, there should be an area, right? Did we do something wrong?
Is it because they are two different areas, hence they cancel each other out?
Can area cancel each other out? Area cannot be expressed in a negative, right? Okay, so let's check. Let's check. Let's do composite areas, meaning let's do it area 1 tamba area 2. Let's cut it somewhere here so that we will get area 1 over here, area 2 over here, okay? And then tamba. So when you do that, we are just using the same function again. However, we are just changing the limit, right? What's the limit of the first one? What's the limit of the first area? This area over here. What will you use as a limit? So it will be x squared plus 20x. You evaluate it from
0 to 10.
0,
Negative 10 to negative 20.
negative 10 to negative 20. Not negative 10 to negative 20. You start here going there, right? So this is negative.
Negative 20 to negative 10.
Okay, so negative 20 up to negative 10. Okay, lower limit, upper limit will be this one. While the other one is going to be evaluated like what? x squared plus 20x evaluated from this point onwards. Negative 10 up to 0. Correct? Okay. Evaluate. Give me the area. So here, what's your area here? What's your area here? From negative 20 to 10.
Got negative 100.
Negative 100 SQU. How about this?
Same, negative 100 as well.
This one, negative 100 as well? Are you sure?
Yeah.
Lower limit. Remember, upper limit minus lower limit.
100.
It will give you 100 SQU. Correct? Okay. So what does this investigation tells us? Okay. When you are using integration to find area, okay, the direction where the area is located affects the area that you are getting, affects the value of the area that you are getting. Okay, we are using dx. That means we are using the x-axis as our divider. Okay, so we call this one now as, since we have dx, then that means the x-axis, axis of integration. Okay. Now, whatever area that is above the axis of integration will be given as negative because it is now above the axis of integration. And this one now tells us that the area below the axis of integration is now going to be represented by a negative. But we know that area cannot be negative, right? There's no such thing as negative area. So this is just the effect. This is just the effect of the position of the area. Okay. So just like vectors, if the vector is going up, it's positive. If the vector is going down, it is negative. It's the same idea as that. So to counter it, you have two methods to counter it. If it is below, you reverse the limit. That's one method. Or that is, for me, is also confusing, so I don't use that. What I do is I just use this. I put a negative sign in front. A to B, f of x, dx. Okay? I use this, or we use this, if I see that the area is below the axis of integration, and you use the positive one if you see that the area is above the axis of integration. Clear? You understand? So it is not correct. It is not correct to integrate it directly from negative 20 to 0. You understand? So that it's important for you to graph first so that you can see what are areas below and what are areas above so that you know how to split them into two. Clear? Okay? So the proper way of solving it is this. Okay, these two. But then that is now area 1 and area 2. So tambak. Okay? But this one is expressed with a negative in front using this. Clear? Okay, let me fix that. Let's cheat. Let's copy this one. No, yeah. This is already the final answer. Okay. So this one now is no longer negative. That becomes positive. So area is equal to ini tambah ini. So total area is equal to 200 square meters. Okay. Clear? Okay. I think that is it for now. You can now enjoy your rest and your weekend. See you all again next week. Okay. Goodbye, everyone.
Thank you, teacher.